It's 2 weeks from today because I always promise 2 weeks notice. So it'll be on the 15th. And by the way, we don't come into class on the 17th. That's fall break. We also don't come to class on the 18th, but nobody ever comes into class on the 18th, so like, big whoop. But anyways, we get a day off. We get a day off.
Thursday, 17th, start the fall break?
Yep, yep. So the midterm exam is October 15th, which is Tuesday. By the way, October 17th is fall break. So what is it going to cover? It's going to cover everything we get through this Thursday.
Cover?
Yeah, so that's the material that's going to be on it, is everything that we've covered up through this Thursday to this Thursday. There won't be anything on it from next week. And let's go see where we are. Looks like we're on chapter 4. Have we finished chapter 4? Let's take a look how far we are in it. And it didn't save our place.
I know we just started it, I think.
Oh, come on. Alrighty. Well, I'll post another notice because I'm going to post that you get to use your PowerPoints in your notes and stuff like that. So there'll be another announcement pretty soon. Chapter 4 through pages 15. Yep, okay. So we've just started it. However, it's going to be a pretty fast chapter because we already know how to use if statements and things like that. So, when you're writing your if statement, if you stick a colon there, it breaks it. No colons after for statements, no colon after while statements, no colons after if statements. Because it's the same as doing that. If the score is greater than 90, do absolutely nothing. You don't want to write an if that says if something, something, do absolutely nothing. So leave the semicolon off there. And I went into a lot of trouble about talking floats and doubles, testing them. You got to take the difference between the expected value and the value of the variable and see if it's less than a certain error amount, right? We talked about that. Expanding the if statement. If the score is greater than 90, the grade is equal to A, and then print good job. The curly braces are a block of code. If you have an if statement, you can have either one statement that's not in curly braces, or you can have multiple statements as long as they are in curly braces. It's not like Python where just indenting something automatically makes it a block of code. You have to use your curly braces if there's more than one. Okay, so let's veer back and talk about the homework assignment, because our homework assignment was to take our guessing game and add a counter to it. Why is it like that? Oh wait, is that the video? Looks like I have them swapped. The video and the lecture notes are swapped. I'm sure you'll be able to find it if you have to. And I'll swap them. All right. So we had a guessing game in here, didn't we? Where did we do our guessing game?
Homework 7, right?
Yeah, homework 7.
Yeah.
I wonder what lecture that was from. Was it the guessing game due today?
No,
Tomorrow.
Yeah.
Well, then it should have been this lecture. Okay, anyways.
I do remember, I think you did assign it last Tuesday though, right?
Well, that would explain why. Let's go look at those notes. So lecture I, random numbers. Yeah. There we go. There's our guessing game. Right, we get a secret number and we have a while loop. Well, I'm not going to give you the answer right here, but let's go ahead and do a loop that does something similar. If you feel like typing along, great. If you don't, that's okay, because this is going to be an example so that we can add a counter to it. I believe we're on K, Lecture K. Go and grab my boilerplate. I'm going to go look at Homework 7's notes exactly so that I recall exactly what we're doing. All right. Modify the guessing game to have a counter that shows the user how many guesses they've made so far. All right, I made this too easy because I should have also made it quit after a certain number of guesses, right? You could guess no more than 10. That would have been cool. So also, try to make it stop if they enter more than 10 guesses. So that's optional, but I'd like for you to do it. All right, there's my boilerplate. Okay, we're just going to write a simple loop. It's not going to be the guessing game. This loop is just going to keep going until you type in. Right. So cout less than quote. Enter a letter. If it's in, we stop. \n. Semicolon. And we need a string to hold our letter. So string letter. We need to let them type it in. CIN greater than letter. Now we're going to have a while loop. While letter not equal to capital N, end quote. We're going to print a message. Cout okay, comma great, \n, end quote, semicolon. And now we need to ask them again. Enter a letter. If it's in, we stop. So I'm just going to copy that. I'll paste that there. But I'm going to make it say enter another letter. And then I need another CIN statement. CIN greater than letter, semicolon. After it, we're going to print all done. Cout less than quote, all done, \n, end quote, semicolon. I think you probably see the applicability of the guessing game, right? Except this one's just running until we type in N. But we're going to add a counter to it. So let's run it and make sure it works first. Sorry guys, I've lectured a long time today and I've almost lost my voice. All right, so enter a letter. If it's an N, we stop. So A, B, C, N, and it finally stops. All right, let's make a counter. So if you want to have a variable that increments above the loop, unless you made it a for loop, which we could have, but we didn't, we need to declare our variable above the loop, just like you said. So int counter equals 0, semicolon, or count. I think I told Serena count, but whatever. You can use count. Counter plus plus, semicolon. So let's print that out. Cout less than, quote, that was turn number, end quote, less than, counter, less than, NDL. Let's run it and see what it does. So enter a letter. A, B, C, D, E. And we finally get tired and we type in an N. All done. That's kind of like our guessing game, but our guessing game was a little bit more complicated, right? It had some code down here. To further simulate our guessing game, why don't we put an if statement down here? If, parentheses, letter equals quote N, end quote, in parentheses, Cout less than you win. They typed in an N, they won. I know it's silly, but you win, \N, exclamation, \N, end quote, semicolon. Else, Cout less than, quote, sorry, ran out of turns. Now that's implying that we're going to make our program quit after a certain number of turns. So we're going to put an if statement in our while loop. And if our counter is greater than or equal to 10, we're going to break out of the loop. Or we could just modify this. But let's put it here, right? We're going to put an if statement here right after where it says that was turn. Oops, sorry. So I'm going to hit enter there and do if, parentheses, counter greater than or equal to 10. They've used up too many turns, right? If counter is greater than or equal to 10, break. So enter a letter. If I keep putting in letters, once turn gets equal to 10, it's going to stop. Sorry, ran out of turns. If we stop beforehand, then by the time we get down here, letter will equal N, and it won't say ran out of turns. So I'm going to type in some letters, and then I'm immediately going to type in an N, and it says you will, because we didn't run out of turns. That makes sense, gang? How that applies to your guessing game? Some people, if you have an if break, like to put an else in there, like this. Else, open curly brace, tab those guys over, and close. But it's not necessary, because if it breaks out of the loop, then obviously it's not going to be able to get down here. And if it doesn't break out of the loop, obviously it is going to get to that. But some people like the way it looks. Don't got to do it that way, but you can. All right, anybody need typing time? All right. I'm going to zoom out the text a little bit so we get more of the page on the screen. All right, so let's change it so that we ask how many turns they get. So let's change that 10 to max_turns. Well, we don't have a variable called max turns yet. So up here, we're going to define it. Int max underscore turns, and we're going to ask them. Cout less than, I guess I can zoom it, you know, like that. So I just changed that line. I just added that. And we're going to cout what is the maximum number of turns, question mark, to play, question mark, space, space, end quote, semicolon. CIN greater than max underscore turns. All right, so that's cooler, right? We didn't have to let them type it in. We could have just said int max turns equals 10. Give them 10 turns. Let's try it out. What's the maximum number of turns to play? 3. Enter a letter. A, B, C. Sorry, ran out of turns. Okay, I like that better because we don't have that so-called magic number down in here. Instead, we have a variable. That's the right way to do it. Even if we weren't going to let them change it, even if we just did int max turns equals 10 and we didn't do this stuff, don't make the change I just made, right? Because I'm going to undo it immediately. But there, right? Now it's easy to find max turns. Okay, I'm going to undo that change that I just made. All right, I want to talk about structures now. We're going to veer off from what we have been doing. What is a structure? It's a collection of data. For example, what if we wanted to track patient data and we wanted to track their name and their address and their birth date? Well, in the past, we would have just created 3 variables down here, right? Name and birth date. Instead, we're going to make a structure for that. Struct, S-T-R-U-C-T, patient. Now, your structures in your classes should begin with an uppercase letter. That's just convention. You don't got to do it that way, but it's convention. All right. Struct patient. And every patient has string name. Every patient has a name. Every patient has an address. And every patient, whoops, how about that for a number of S's? Every patient has a birth date. Make sure you get your close brace and a semicolon. If you're doing Java, you don't put the semicolon there. We're getting towards object-oriented programming. The difference between a class and a structure is that a class also has methods in it. A structure does not. But we're taking our first step. All right, let's create some patients. And I'm just putting this up at the top of main to make it easy to find. Patient P1, comma P2, semicolon. P1.name equals Mickey Mouse, end quote, semicolon. And just for giggles, I want to find out when the first Mickey Mouse cartoon was. Steamboat Willie. It's the name of the cartoon. When was that released? 1928. Okay, so that's his birth date. So P1.name equals Mickey Mouse. P1.address, he lives in Disneyland. Disneyland. And P1.birth equals 01/01/1928. How about that? Mickey Mouse is 97 years old or something like that, 93 years old. But we have P2. We can store more data. P2.name equals, quote, Bugs Bunny, end quote, semicolon. P2.address equals, quote, where did all those equals come from? I need to swap keyboards. Equals 123 South Carrot Avenue, end quote, semicolon. And his birthday. I don't remember when the first Bugs Bunny cartoon was. So I'm going to Google that one up too. First Bugs Bunny cartoon. 1940. So P2.birth equals, quote, 02/02/1940, end quote, semicolon. So if I put a space here, anyways, check it out. One variable is holding 3 pieces of data now rather than just one. And then we have another variable here holding more pieces of data. So we could write a function that would print that data out. First, I'm going to compile it and make sure that I don't have any syntax errors, so I'm just going to run it. All right, great. It ran. Close it. Now I'm going to write a function that'll print our patient out. So void space print, parentheses, and it's going to accept an argument that's a patient. So we need to make a parameter variable to hold it. Patient space P, end parentheses. Bless you.
Thank you.
Open brace. Cout less than quote, patient name equals space end quote, less than P dot name, less than ENDL. And then do the same thing for the address and the birth. So cout less than quote, patient address equals end quote, less than P dot address dot ENDL. Oh, wait, where'd that come from? Not dot ENDL, less than ENDL. And then cout less than quote, patient birth date equals space end quote, less than P dot birth, less than ENDL. Now I'm going to print out our patient after we create them, right? We made a patient called P1 and we assigned some data. So why not do print, parentheses, P1, in parentheses, semicolon. And then after the other one, after Bugs Bunny, do print, parentheses, P2. In parentheses, semicolon. And it should print out both of our patients. And so it did. Mickey Mouse, Disneyland, 1928. Bugs Bunny, Carrot Avenue, 1940. Maybe we'd like some blank lines before and after. So in front of all that information, I'm going to print out an ENDL. And after all that information, I'm going to print out an ENDL. Just to be different. All right. Mickey Mouse, Disneyland, 1928. Bugs Bunny, Carrot Avenue, 1940. So the structure is a blueprint. And P1 and P2 are objects built from the structure, from the blueprint. Just like you have a blueprint for a house. You buy a fancy blueprint and you hire some builders to go and build you a house. This is a blueprint. These are the objects. And an object contains multiple pieces of data. This one contains 3 pieces of data, but you could make an object that contained hundreds of pieces of data, or an array of elements. Yes, sir?
Why do you need to have CL ENDL after you have inlines all over all your CLs?
Oh, I just wanted it to look, yeah, why do I have this? Because I wanted it to be nicely spaced out like this. Did I have to have them? No. I just like the blank lines. That's the only reason.
Okay.
Come on. Oh.
Alrighty, so we're not going to do anything else with structures today, but we're going to keep you doing that. We're going to keep doing that. So, the structure is a blueprint. So we have some kind of blueprint called patient. I'm just going to call it Pat. And it had 3 pieces of data in it, right? It had a name, it had a birthday, and it had an address. Not quite in that order, but that's okay. And so then in our code, we created a patient. We said Pat, patient P1, comma P2. I'm just going to do P1. What that does is it runs out. This is just a blueprint. It's not anything. But this runs out into memory and it creates a patient object. So now we have an object in memory with 3 pieces of data.
Oh my goodness.
And so that object has space for 3 things. And so we wrote Mickey in it. We gave him a birth date. And then we gave him a place, Disneyland. So this got allocated into memory. I wonder how much RAM that's taking up. Then we said patient P2, and we put more information in it, right? So when we said patient P2, it ran out and it made another one. It made Bugs. And he was born in 1940. And he lives somewhere else in Carrot Lane. So each one of these has an address. Like this might be an address at 0, 1, 2, 3, 4, 5 or whatever. So P1 is pointing to that address. 0, 1, 2, 3, 4, 5. This one's got a different address. 0, 1, 6, 7, 8, whatever. And P2 has got that address in it. Let's find out how much RAM, how many bytes these things are taking up. So let's go back here.
Let's go back to test some numbers.
And say out, cout, listen, quote, P1 uses, end quote, listen, size of, parentheses, P1, in parentheses, listen, quote, bytes. Wait, no, sorry. Listen, quote, space, bytes, \n, end quote, semicolon. And let's do the same thing for P2. Let's just copy that. Change all the P1s to P2s. All right, it says P1 takes 84 bytes and P2 takes 84 bytes. Now that doesn't really make a lot of sense to us, but let's figure out how long a string is. Because it's made of 3 strings. So cout listen, quote, a string uses, space, end quote, listen, size of, parentheses, string, in parentheses, listen, quote, bytes. \n, end quote, semicolon. We're going to find out how much space a string takes. So a string uses 28 bytes. And what's 3 times 28? My brain doesn't work enough to figure that out. So I'm going to use Google. 3 times 28 is 84. What do you know? That's how many bytes P1 and P2 took up, right? So just like I was drawing over here, this object's got 3 strings in it, each one taking up 28 bytes for a total of 84 bytes, right? So the whole thing uses 84 bytes, and each time we create one of these, it uses up another 84 bytes. What if we wanted to know where in memory it was stored? What byte number, what memory address it was? Let's find out. Cout less than quote P1 is stored at address space end quote less than. Now this is going to look a little bit weird, sorry. int parentheses ampersand P1 close parentheses less than ENDL. What this does is it gets the memory address of P1. It gets the so-called pointer to P1, which byte it's stored in. And so it's stored at address 15727, whatever. I'm going to copy that because I'm curious about P2. So I'm going to copy all that and paste it and make it say P2. P2 is stored at that address. So if we talk about structures and classes for 5 or 10 minutes every day that we're here, y'all are going to be object-oriented gods by the time you're done with it. Okay, so P1 is stored at this memory address and P2 is stored at a different memory address. Notice that they're kind of swapped. P2 is at a different number. It's at a smaller number. Well, C can create these variables and store them in any order that they want. We don't have any control over what bytes it's storing this stuff into.
That's strange.
What it's doing is it's last first. The last thing created is at the lowest memory address. And the first thing created is at the highest address.
Question?
Yes, sir.
So for my string, it actually saying that it reads 28 bytes.
I think that's what mine said.
Oh, I thought you said.
I think I said 24, but
Oh, no.
looking at it, it says 28. All right, anybody need typo help? Yeah, yes, sir.
I don't have any typos.
Mangled. That's all right. All right, back to the PowerPoints.
Probably because I was typing too fast.
So if else, guess what? We know how to use if else, right? If expression, do statement 1, else do statement 2. For example, if this expression is true, it's going to perform that block of code. If the expression is false, it's going to do that block of code. And in flowchart, if number modulus 2 equals 0, 0. What is that doing? It's dividing by 2 and getting the remainder. Well, if you divide by 2 and get a remainder, then that means that it's an odd number, right? Like 3 divided by 2, the remainder is 1. So number modulus 2 equals 0, if it's false, it means the number is odd. Let's play with that idea a little bit. Maybe up here before the maximum number of turns business. So let's get a number. Let's declare a number. I'm just going to call it num for easy. int num, cout less than quote, enter a number. How about enter a whole number, colon, whoops, that colon goes inside the quote, enter a whole number, colon, space, end quote, semicolon. CIN greater than num, semicolon. Now let's print some information about it, like whether it's even or odd. If num modulus 2 equals 0. If you divide something by 2 with no remainder, it's an even number. Cout less than quote, even number, \n, end quote, semicolon. Else, cout less than quote, odd number, \n, end quote, semicolon. Now let's see if it's evenly divisible by 3. Cout, wait, we need our if statement, right? If, parentheses, num modulus 3 equals 0. If you divide it by 3 with no remainder, then cout less than evenly divisible, or a multiple of 3. A multiple of 3. \n in parentheses semicolon. Let's check for 10. Do the same thing. If modulus 10, make it a multiple of 10. Heck, we could write a loop that would check all the numbers. Let's do that. Let's use a for loop. So instead of doing 10 like that, I'm going to do for int I equals 4 semicolon. I is less than or equal. What do we want to check up to? 100? 100 semicolon I plus plus. Open curly brace. If parentheses num modulus I equals 0 in parentheses. Cout less than quote a multiple of space end quote less than I less than ENDL semicolon. So if we type in 40, it should say it's an even number and that it's a multiple of 4, 5, 10, and 20. So enter a whole number, 40. It's an even number. It's a multiple of 4, 5. Oh, I forgot, 8. 8, 10, 20, and 40. So how about the number 300? What are its factors? A multiple of 3, 4, 5, 6, 10, 12, 15, 20. Well, let's enter a prime number, like 17. It's an odd number, and it doesn't have any other multiples except for 1 and 17. That's why it's prime. Okay, so we know how to use if-else. We certainly know how to use if. And by now we know how to use if-else, 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 right? We know how to chain those together.
I plus plus, right.
So nested if statements. Nested if statements are just when you have an if and then you tab over and you have another if. Like, what if a moviegoer gets a discount if they're either under 10 or over 65 and it's a G-rated movie? Let's do that. We can do that. But I'm going to stick that up at the top. So way up here above patient P1 and P2. Let's get the age, but let's just set it rather than ask them for it. Age is equal to 7, int age is equal to 7. And let's get the rating of the movie. String space rating equals quote G end quote semicolon. And we're going to find out if they get a low price. Children under 10 get a discount. So if parentheses age is less than or equal to 10 in parentheses curly brace, if parentheses rating equals quote G end quote in parentheses semicolon, or excuse me, curly brace, if both of those things are true, we're going to see out 50% discount on ticket \n end quote semicolon. So somebody look at our code and without running it, tell me if it's going to print that. Is that a yes or a no? Are we going to get our discount based on the data that we have up there?
Yes.
That's definitely a yes. So above that stuff about Bugs Bunny and all that, 50% discount on ticket, yeah. When you have nested ifs, you can rewrite them using and. Nested ifs can be rewritten using and. Now, have I mentioned already that and is written like that? I think so. So if parentheses, age less than or equal to 10, and still inside the parentheses, rating equals quote G, end quote, semicolon, curly brace, C out less than quote, like I said, 50% discount, end quote, excuse me, backslash n, end quote, semicolon. But since we only have one if, it's easy to add an else, right? We can put an else here. Else, I'm going to remove these curly braces. If you only have one line of code, you don't have to have curly braces. So else, C out less than quote, sorry, no discount, backslash n, end quote, semicolon. So you see what I'm saying? This, we had a nested if to check to see if it was a 50% discount. But with one line of code and using and, we were able to do the same thing. This is a better way to do it, usually. Why do I say that? Because we were able to easily throw in an else. We'd have to put else in two places here to get the same effect. We'd have to put an else there and an else there. But here, just one else covers it. But what if we wanted more choices? Like what if people over 65 get a 25% discount, ignoring the rating? I guess because only children get, you know. So I'm going to insert an else if, parentheses, if age greater than or equal to 65, you're a senior citizen. So else if age, parentheses, age greater than or equal to 65, C out, arrow, arrow, quote, 25% senior discount, backslash n, end quote, semicolon. And in Python, I bet half y'all remember because you took fundamentals. If not, no problem. In Python, you say elif. But this language doesn't have elif, it has else if. For some reason, Python considers else if a syntax error, which I think it shouldn't be, but whatever. Alrighty, and so 50% discount on ticket, like I said, 50%, but what if we change our age? I'm going to change my age to 77. They're not a child anymore, they're a senior. So it says 25% senior discount. Now what if it's between the two, right? What if it's a 37-year-old? Well, they don't get either discount. Not fair, but there we go. Sorry, no discount. Right, except Serena, who types twice as fast as all of us. I'm teasing you. So now we know how to use if, else, if, and we know what a nested if is.
Hashtag pressure.
So if, else, if tests a series of conditions until one is found to be true. It tests a series of them. And they're mutually exclusive, right? We're only going to either get that one, or that one, or that one.
What the crap did I just do?
Need me to come look, or you okay?
Yeah.
All right, let's take a look. You will write a program that asks the user for 4 pieces of data, as described below. Your program will perform the following tasks. Prompt the user for their age, prompt them for their years of employment. If they're greater than 17 years old, and their years of employment is greater than 2, we print you get free checking. If their age is less than 17, or their years of employment is equal to 0, print enroll in a training program. So what's the symbol for and? We just used it in our if statement. What's the symbol for and?
The double
Yep.
and sign.
Right. What about or? What's the symbol for or?
Or this one.
It's the 2 bars. Yep. Is everybody familiar with that, or just me and Q because he's already done C programming? We all seen that? Thumbs down if you haven't. Okay, okay. So that is or and that is and. Let's give an example of or down here. I don't know what. How about if, parentheses, age is less than 3 or age is greater than 100, see out, you get to see the movie for free. Now that's stupid, right? But whatever. So, my typical example is you are sick or tired, right? Bool sick equals true. Bool tired equals false. If, parentheses, sick or tired, in parentheses, see out, stay home, backslash in, end quote, semicolon. Else I have to go to work. Else, I'm going to remove the curly braces, and I always mess y'all up when I do that, but take the curly braces out. Else, see out, less than, quote, go to school. So if we are sick or we are tired, we get to stay home. So it's going to print stay home, right? Because we are sick. And it says stay home. But what if we changed it to and? And means both of them are true. Are we going to get to stay home? Is it going to print stay home, or is it going to print go to school?
Go home.
Stay home.
Nope, because we have to be both sick and tired to stay home. And are we tired?
Nope.
Nope. So we have to go to school. So when we run it now, it's going to say go to school. But if we change it back to or, then it's going to print stay home, because we're allowed to stay home if we are either sick or tired. Must be nice, right? You get tired, you get to stay home. There we go, right? So stay home. That's the way or works, is one or the other has to be true. So this is or, the two vertical bars, one or the other must be true, or both. Technically, if you're a computer engineer, you may have heard the term exclusive or, and that's not an exclusive or. So that's an or, and ampersand ampersand is an and. Both must be true.
Is computer science the same thing as computer engineering?
There's a little bit of a difference. Alright?
A little bit of a difference?
Yeah.
Science, you don't have to know engineering. Engineering, you have to know science. I don't know if that's strictly true, but if you get a computer science degree, then you're not actually learning how the circuits work. You're learning how to use them. I don't know if that's an exact description, but then computer engineering is also about the mechanics of building them. Computer engineering versus computer science. Both majors are heavy in theory. However, the key difference is that computer science focuses on software, and computer engineering is more about hardware. Yeah. All right, I think we've gone far enough today. We have a homework assignment to work on. Let's look at the rest of this. So you've asked them their name. You've printed out something about free checking and enrolling in the training program. Then you're going to do something else. And the last time I did this, it came out stupid, so I may modify this a little bit. Prompt the user for how many calls they've made, and then prompt the user how many minutes they've talked. If the calls is greater than 100 or the minutes is greater than 1,000, print upgrade to the higher plan. Else, if the calls is less than or equal to 100 and minutes is less than or equal to 1,000, print stick with the current plan. Else, if their calls equal 0, print you might as well stick to the current plan. And then one last one. Else, print, gee, I don't know. Because none of the others happened. And it'll be interesting to see when we get there. Like what happens if we enter 55 minutes maybe it'll say, gee, I don't know what to do with your plan. But maybe it's going to say that. Okay, so that's our requirements. You're going to ask for their age, their year of employment, how many calls they've made, and how many minutes they have talked. We could do it old school, like, in the early 2000s, and ask them how many text messages they're going to send. Nobody gets limited text messages anymore. That makes sense, gang? Looks like a good homework assignment. All right.
Hey, can you go back to like the code?
Go back to which?
The
The code? All right, sure. Yeah, I didn't leave that up long enough. Sorry about that. Yes, sir.
For some reason, the code about the movie type stuff,
Yeah.
it wasn't working.
Well, I see it up here. 50% discount on ticket. Like I said, 50% discount. It's just up at the top because we put it right under main. Yep, see, it's right there. If you cut that and put it at the bottom, then it'd be at the end rather than the beginning.
Oh.
Yeah.
Alright.
You're done?
Yep, we're done. So there's a Dropbox. You can upload this into K.
Lecture K.
Did you upload this one? Yeah, this one.
Yeah, I'm going to upload that one. You don't have to type it all in. It's 2 pages of text.
I would hate to type 2 pages of text or whatever.
But I'll copy and paste it into our notes as well, so it'll be in both places.
See ya.
Bam. I got source.
What time do they?
Yeah, today's the 1st, and so it's homework K. Or lecture K.
Our homework.
Oh, it'll be due next on the 9th.
Okay.
But if you need extra time because you're not going to be here, just text me about it, okay?
Okay.
Because I know you're going to be missing a class or two.
Okay.
Oh, October 9th?
That's when the homework will be due, yeah.
So it's due on Wednesday.
Yeah. I don't know why I didn't make it due on Monday, but I just told Minkyu it was Wednesday and I'm not going to change it, so yeah.
If you need extra time, please. I'm just kidding.
But yeah, if anybody needs extra time, just text me and we'll talk about it. But he's talked about it to me in advance, that's why I know.
Trying to do a paper while in class. That's not fun.
No, that doesn't sound fun.
Well, that's the reason why I'm late for class, because I'm trying to type a paper for science
Oh, yeah?
for Thursday. And a friend of mine's helping on it.
Cool.
I mean, papers get ugly, especially in Comp 2.
They do, don't they?
It's been a long time since I've had to take Comp 2, but I would agree. Yep.
Especially, well, our Comp 2, we do it paper after paper, and it relates to your project, but still, it's...
Okay. Alright. What did you want to show me, Professor?
Oh, yeah, yeah. So do you got NetBeans installed? Let me come and look as soon as I post this link here, okay?
Let me zoom in my lecture K real quick.
Sure.
Okay, it's all submitted.
Alright, just a sec.
Alright, I'll move over here. Yeah. So weird though, you're talking about computer science, engineering. The prose actually makes it very similar to the here.
Oh yeah.
I think there's only like 2 or 3 classes that extra that the CS majors have to take.
Oh, okay.
Yeah. Well, yours. Data structures or pretty adds.
Yeah.
I think just statistics.